Prior to discussing the announcement, it is essential to comprehend what accelerators for particles are. The enormous CERN's Hadron Collider, also known as the LHC, is a 17M superconducting ring of magnets, including the largest and most powerful accelerator for particles. It symbolizes the highest level of human achievement in science. In fact, it is powerful enough to recreate the circumstances of the universe's birth. But could this apparatus be used to unlock the universe's secrets? Or perhaps something much more terrifying? CERN, established in 1954, is one of the most reputable research institutions with 23 nations as members and thousands of scientists. It serves as a hub for teamwork and creativity. CERN runs the LHCIT's flagship undertaking, but it is only one component of an extensive system of accelerators and experiments. Imagine a racetrack, not for horses or cars, but for subatomic particles racing against the clock in space itself. The LHC speeds up protons to velocities near the speed of light, sending them into collisions that imitate the energy levels present during the Big Bang. These encounters multiply the temperature by 1,000,000 hotter than the sun's core. The protons are guided by thousands of magnets on their journey. Despite the complexity, these magnets are maintained at temperatures colder than outer space. The LHC's beams are designed so that 4 collisions occur around the accelerator ring, where 4 particle detectors are located: LHCb, CMS, ALICE, and ATLAS. Each serves a singular goal, examining various aspects of particle physics. Together, they act as enormous cameras recording images of the collisions. Scientists then sort through the aftermath, searching for clues such as the elusive Higgs boson. It's also known as the God particle, and other phenomena that hint at the universe's fundamental building blocks. By examining the microcosm, we gain an understanding of the macrocosm. But with each answer comes a new question. And with each new discovery, it's a new challenge. The LHC is more than just a scientific instrument, it is a testament to human inventiveness and curiosity. It exemplifies our unwavering pursuit of knowledge and the need to comprehend the fundamental forces that shape our universe. However, as we push the envelope, we must also consider what we know, the ethical and existential questions that arise. What dangers are there in investigating the unknown? Could our pursuit of understanding accidentally unleash forces we cannot control? Within the hallowed halls of CERN, where the limits of human comprehension are constantly tested, a revelation has emerged, sending a chill even down the spines of the most knowledgeable scientists. Brian Cox, a former CERN researcher and a leading authority in particle physics, has recently made a statement that has both enthralled and terrified the world. His remarks reverberate with eerie clarity. The purpose of the Large Hadron Collider at CERN is to make a miniature Big Bang. Yes, that's true, a scaled-down version of the very event that created our universe. The physicist continued, explaining the profound implications of this goal. He emphasized the LHC's remarkable potential to discover new phenomena, including the secrets of the Higgs boson and a mysterious substance known as dark matter, a significant component of the universe. Imagine having the power of creation in your grasp, the ability to recreate the very essence of existence. It's a tempting possibility, but one that carries risk. The compact Big Bang is more than just a theoretical concept. Within the LHC, it becomes a tangible reality. Infancy. It's like standing at the dawn of time, witnessing the birth of everything. However, with such power comes responsibility and the looming question: what if something goes wrong? In fact, something did go wrong. Anatoly Bugorsky, a Russian physicist, suffered an incident in 1978 that would forever alter the course of his life. A malfunction caused his head to enter the direct path of a proton beam. This beam, with a force beyond comprehension, passed through the back of his head, through his skull, and exited through his nose. Bugorsky experienced something bizarre. He saw a flash brighter than 1,000 suns, but felt no pain. The beam carved a trail of destruction through bone and tissue. Yet, He remained conscious and walked himself to the medical facility. What followed was both fascinating and horrifying. The beam caused localized tissue death, resulting in hearing loss, facial paralysis, and partial impairment. Yet, astonishingly, Bogorsky's intellect remained intact. He even continued his scientific career. This incident was not only a personal tragedy, but a powerful lesson. It highlights the immense power and danger of particle accelerators. The risks posed by such devices, including the LHC, must not be underestimated. These risks include unexpected reactions and manipulation of the very fabric of space and time. These are not the fantasies of science fiction, but genuine concerns. Raised by scholars, among the most intriguing and alarming possibilities is the idea that the LHC could create a miniature black hole. Black holes are regions of space-time with such strong gravity that nothing, not even light, can escape. They are cosmic scavengers that devour stars and linger in the universe's darkest corners. The notion that such an entity could be created, even on a tiny scale, has shocked both the public and scientists. Could such a black hole grow uncontrollably, consuming the Earth from within? CERN scientists have assured the public that any black hole produced would be unstable and would evaporate almost instantly. Still, the mere possibility has sparked intense debate, fear, and awe. It is essential to understand how a black hole might form in the LHC. This idea relates to the fundamental mechanics of particle accelerators. When protons are smashed together at near-light speeds, the energy released is immense enough to distort space-time itself. Imagine a trampoline stretched taut, then a heavy weight suddenly dropped on it. The fabric warps and curves. If the weight is heavy enough, it might create a depression so deep that anything near it is drawn in. That's a crude analogy for the potential consequences of the LHC in the world of quantum physics, where the universe's laws are both bizarre and beautiful. Some theories suggest hidden extra dimensions may exist within our reality. If these dimensions can be accessed through LHC collisions, it could result in a funnel of force that produces a tiny black hole. This strange motion of particles has even captured the attention of notable scientists, particularly the late Stephen Hawking. In his writings, he warned about a scenario in which the Higgs boson could become unstable at extremely high energy levels. This instability could trigger a catastrophic vacuum decay, a cosmic event that would not only destroy Earth but ripple through the entire universe. Renowned British cosmologist Sir Martin Rees also expressed concerns. In his book about humanity's future, he explored potential dangers from particle accelerator experiments, including those at CERN. His warnings went beyond theory. He described a worst-case scenario in which an experiment could cause a phase shift, creating ripples through space-time and triggering a universe-ending catastrophe. Rees believed that, while the chances were very low, they were not zero, and even the slightest chance should give us pause. The risks are astronomically high, and the margin for error is vanishingly small. CERN researchers have run simulations, studied probabilities, and tested theories to ensure the LHC's safety. In fact, Brian Cox himself emphasized the importance of responsible exploration, acknowledging the concerns surrounding the LHC. He stressed that strict safety protocols and rigorous procedures are in place. Cox reassured the world that the LHC are still within the natural limits the Earth experiences. Even if a black hole were formed, it would be so tiny and unstable that it would disappear in a flash, a phenomenon predicted by Stephen Hawking's theory of radiation. Such a black hole would last for only a brief instant, a fleeting glimpse into the universe's abyss before vanishing. Their LHC experiments might open the door to another dimension or universe. This notion, despite the skepticism of the scientific community, has captured many people's imaginations and evolved into a subject of interest, dread, and even folklore. What lies beyond what we see? Could we accidentally activate forces or entities that we are unable to comprehend? The concept of opening a door to hell has even generated sensation in various media, adding fuel to the uncertainty. But how did this concept come to be? Furthermore, what does it imply in the context of scientific research? Parallel dimensions are not a new concept in physics. The leading theory of strings, a potential theory of everything, suggests that there might be more than just the three usual dimensions, one of time and three of space. These extra dimensions could be compactified or hidden from our view. But in theory, they could be accessed or revealed under extreme circumstances. Now, consider the LHC to be a kind of cosmic key unlocking doors that have remained shut since before time began. If protons collide with unimaginable energies here on Earth, they might, theoretically, tear holes or ripples in the fabric of space-time, constructing temporary portals or ways into these esoteric realms. While much of this remains in the realm of science fiction, it's difficult to ignore the weight of the possibility. At its core, the topic raises a vital question: responsibility. Should we interfere with forces that could potentially alter the very fabric of reality? Using the LHC's capacity to examine the deepest corners of the universe, ought we to be concerned about the potential outcomes? As scientists like Brian Cox continue to unravel the mysteries of the cosmos, one thing remains certain: the pursuit of knowledge is fraught with danger. The search for the unknown is filled with both seen and unseen risks. The LHC story is far more than just a sci-fi fantasy. It is the tale of humanity's insatiable curiosity, and with every experiment and discovery, the universe reveals itself to us in more intricate and surprising ways. However, the question remains: when we uncover the universe's most profound secrets, are we truly prepared for the repercussions? Or do we stand, like Borsky's man, at the edge of the unknown, looking into a universe we may never fully comprehend or control? The answer to that question belongs to the future, a future full of both potential and peril. And as we approach the edge of discovery, we must ask, are we truly prepared to deal with whatever we might unleash? As we consider the future of the LHC and the possible dangers and benefits of its revolutionary experiments, it is essential to acknowledge the broader context of our scientific curiosity. This is the Large Hadron Collider, not simply a device made to answer theoretical inquiries about particle physics. It symbolizes the essence of human inquiry. Since the beginning of civilization, we have endeavored to comprehend the world around us. Philosophers in ancient Greece, including Aristotle, sought to unravel the mysteries of the universe using reason and observation. Thousands of years later, the Renaissance brought the rise of modern science. People like Galileo and Newton transformed our understanding of the world. The LHC of today is the latest and most powerful instrument in our ongoing quest to discover the secrets of the cosmos. However, with great power comes great responsibility. Delving into the deepest elements of nature pushes not only the boundaries of scientific method, but also of human control. The ability to unlock an understanding of dark matter, antimatter, and the fundamental nature of reality itself is incredibly alluring. Nevertheless, each step into the unknown must be taken with caution. Our current understanding of physics is incompleteness, and with incompleteness comes the uncompleteness. Like the uncompleteness or unforeseen consequences. The idea that a particle accelerator might, because unanticipated events such as the creation of black holes has captured the public imagination. Yet, the scientific community has long recognized the complexity involved. Most CERN scientists are confident that the accelerator will not result in any disastrous event. They rely on extensive modeling and theoretical frameworks to ensure the safety of their experiments. Theories such as string theory suggest that extremely small black holes could be produced. However, they would rapidly decay due to quantum effects. Even if such tiny black holes were created, their lifespans would be infinitesimally short. They would vanish almost instantly. Yet, despite these assurances, critics argue that no prediction can account for every possible outcome, the nature of the LHC's experiments places them at the very edge of contemporary scientific understanding, while grounded in existing theories. The LHC simultaneously creates conditions for entirely new phenomena that might not conform to our current models, as speculative fiction and thought experiments have long warned. The consequences of tapping into unknown forces could be more profound than we can imagine. Some critics worry that our society is so focused on achieving knowledge that we might fail to comprehend the consequences of our actions. A growing philosophical debate questions whether humanity's pursuit of progress is like chasing a falling object blindly, recklessly. Some argue that we should proceed cautiously, focusing on research that offers immediate benefits to society, rather than risking global consequences in pursuit of lofty goals. Others, however, assert that science has intrinsic value. Regardless of the dangers, they believe that true advancement requires the courage to explore the unknown, to face uncertainty, even at great risk. This tension between scientific prudence and unrelenting curiosity is not new. It has surfaced repeatedly throughout history. For example, the development of atomic power brought similar concerns. In the 20th century, nuclear energy had the potential to transform the world, yet it also introduced the threat of nuclear weapons and radiation. Humanity's response was not retreat, but resilience. We continued to explore and develop new technologies. Likewise, LHC research may yield breakthroughs that reshape our understanding of both physics and the universe. It opens new frontiers in science and human potential. Looking ahead, it is also important to consider the ethical dimensions of these experiments. The LHC conducts research in the name of discovery, but is discovery alone enough to justify the risks? Each experiment produces new information, techniques, and technologies, many of which find applications beyond physics. This acquired knowledge can lead to breakthroughs in fields ranging from materials, science, to medicine. However, with the potential for unforeseen consequences always looming, scientists must maintain an ongoing dialogue with the public and policymakers. Transparency is crucial, ensuring that the benefits of research are weighed against its risks. Ultimately, the LHC is more than just a scientific experiment. It represents humanity's relentless drive to explore the boundaries of possibility. Whether or not we are truly ready to face the consequences of these experiments remains to be seen. But as long as we are guided by a moral and responsible approach to scientific progress, we can believe that the pursuit of knowledge will lead to a deeper understanding of the universe while preserving our future.